This is the Math 021 statistics handout, which is pretty much designed to introduce you to statistics a little bit, right? So in Math 021, we just deal with very introductory statistics, but in general, statistics really it's all about collecting, organizing, and analyzing information, right? Data, right? So you're going to collect info, you're going to organize it, and you're going to analyze it. And I mean, for the most part in Math 021, we are just going to really focus on the organizing part. When you get into like a statistics class, then you would do more of the collecting and analyzing and making predictions, things like this. Okay, so first I just wanted to show you a couple of quick examples of statistics. One being a poll, right, about the upcoming 2016 elections, right? I mean, the first question was just a question about, do you think that the country is heading in the wrong direction or the right direction, or you're unsure? So you can see some data there. 63% of the people that were polled thought that the country is moving in the wrong direction. 33% think it's moving in the right direction, and then 4% are unsure. Okay, and then there's various polls here: the approval rating of the President Obama, and then a prediction for the presidential election of 2016. Right. So they're assuming that the Democratic candidate is going to be Hillary Clinton, and the Republican candidate is going to be Jeb Bush, and given those two candidates, 49% of the 514 voters who were polled said they would vote for Hillary Clinton, 42% they would vote for Jeb Bush, and 9% were undecided. Okay, and that poll took place from March 1st to 4th, 2015. So this is an example of statistics. It's just simple polls, right, that were taken. Right, 514 people in this case were asked who they would vote for in the 2016 presidential election. 1,036 voters were polled here about President Obama's job, pretty much, as president, and then 1,036 adults were polled here about the direction of the country, right? Whether it's moving in the right direction, the wrong direction, or they're unsure. So that was pretty simple statistics, right? You just people would just answer, you know, wrong direction, right direction, or unsure in this case, and then it would be organized to create a simple little bar graph here. Okay, so that was one example of simple statistics, and the other example is something that I like: baseball statistics. Okay, what you see here is statistics of Derek Jeter for various years. Right, it gives, you know, how many hits he has, how many doubles, how many triples, how many home runs, so on and so forth, how many runs batted in. And it's just a way to organize this data by year, right? This is going by year. This year here was 1995, then 1996, 1997, so on and so forth, all the way out to his final year, which was 2014. Okay? And these are pretty simple statistics. These are known as like the standard statistics. And then down here below, you have what are known as the advanced statistics, right? And most of these are fairly new creations, right? Some people who are big baseball fans might have heard of WAR, which stands for wins above replacement. And you can see Derek Jeter's WAR was pretty good for a number of years. 8.0 is very high, 7.5 is very high, right? And then that one year, 2013, when he played in very few games, his WAR was actually negative, right? Wins above replacement. So these are much more advanced statistics, right? If you're into the baseball, what they do is they refer to these as advanced metrics, right? The word metric pretty much just means like a measure. So these like are advanced measures of Derek Jeter's performance, right? They're not just things that can be, you know, gathered by counting up how many hits he has or how many doubles he has. There's complex formulas that go into these advanced statistics. Okay, so we had an example of pretty simple statistics here, right? And then pretty advanced statistics here. All right. So again, statistics is basically dealing with collecting, organizing, and analyzing data. Okay. So the first example we have here, is a Math 131 statistics student who's preparing a presentation for the Student Achievement Showcase at Brookdale. She's planning to analyze the relationship between the sugar and fat content in different brands of cereals. And they're asking us to organize this data and prepare the graphs for her presentation. And there's the data set that she collected. So in this case, again, the collection has already been done, right? The data collection has already been done, and it's in the form of a table here, okay? So what we're going to do is we're going to try to organize it, okay? So there's 3 different variables here, right? One is the manufacturer of the cereal, another is the amount of fat in the cereal, and another is the amount of sugars in the cereal, okay? So they're asking us first, use the above data to answer the following questions. So what is the qualitative variable, okay? Now qualitative is basically non-numerical data, right? It can deal with, it can be like attributes, like it can be like a color, or in this case it's actually the manufacturer of the cereal, right? So pretty much qualitative data, it really just means non-numerical, right? It's non-numerical data. So the manufacturer in this case would be the qualitative variable, all right? And then what they want us to do is prepare a frequency distribution table for the qualitative data. So we have our frequency distribution table for this qualitative variable, which is the manufacturer of the cereal, right? So you can see the table here has 3 columns to it. The first column has the list of the manufacturers, right? I've taken the liberty of typing them in, right? Nabisco, General Mills, Post, and Kellogg's. Then we have a column for the tally, and then we have a column for the frequency. Now, frequency just means how many. So what we're going to do is we're going to go to our table here, right, which I've taken a picture of, and as I go down the list, I'm going to put little tally marks whenever I reach one of the manufacturers. Okay, so the first one is Nabisco, so I put a tally mark there for Nabisco. This is not going to stay open. And then I have 2 Kellogg's, so I would go Kellogg's, boom, boom, right, tally marks there. Then I have a Post followed by 3 General Mills, so I'm going to put a tally for Post and then 3 General Mills. Then I have a Nabisco and a Kellogg's, so Nabisco, another Kellogg's. Then I have 3 Posts, so I'm going to go 1, 2, 3. And then I have a Kellogg's and 2 General Mills. So 1 more Kellogg's, and then 2 more General Mills, so 4, and then cross it off with the 5, right? When you do tallies, you generally bundle them in groups of 5, so you put 4 slashes, and then you cross it through when you get a 5th, okay? So I've gone through my list, so now what do I have? Nabisco, I have 2 tally marks, so the frequency for Nabisco is 2. For General Mills, I have 5, so the frequency there is 5. For Post, it was 4. And for Kellogg's, it was also 4. Okay? And then now you see below this frequency column here, I have this little funny symbol there, which is actually the Greek letter sigma. And you've seen this probably in a couple of labs previously. What that symbol means, sigma, is it actually means sum. So you're adding up, right? So what is this saying? It's saying you're adding up all the F's, right? And F stands for frequency here, right? So I have a 2, a 5, a 4, and a 4. So when I add up all those frequencies, 2 plus 5 is 7, plus 4 is 11, plus 4 is 15. And I should make sure that this actually matches the total number of cereals that I had. Yes, 15 was my total number of cereals in this sample. So the sum of the F's is 15. So that's kind of like a check that you can do at the end. All right. So that would be my frequency distribution table And what I will do next is I will turn this into graph form. So we're now going to transfer the data from our frequency distribution table and turn it into a bar graph. Okay, so you see I've already taken the liberty of creating the skeleton, if you will, of this bar graph. Right, I have a title here, which I'm calling serial manufacturers. I have my vertical axis, which is going up, right, of course, because it's going to start at 0 and then go up. And then I have my horizontal axis, which is just like an x-axis, right? And I have, under the horizontal axis here, I have labeled the manufacturers, right? So I have a little space here for Nabisco, General Mills, Post, and Kellogg's, because those are my 4 cereal manufacturers. And then what I have is I have my vertical axis labeled with frequency, which again means how many, right? Or the count of each manufacturer, right? So I can go back and look and see what my counts were, right? My counts were 2 for Nabisco, 5 for General Mills, 4 for Post, and 4 for Kellogg's. So I have to go as high as 5. So if I was going to label my vertical axis, what I would do probably is I would go off by ones, right? Count off by ones and say, all right, well, maybe here I would have 1, then here I would have 2, and just try to do this as, you know, accurately as possible. 3, 4, 5. I'm not going to go up to 6, but I'll still write it in 6, right? So that's fairly accurate, right? My spaces there should be as close to close to equal as possible, and it looks pretty good, right? So my frequencies are going from 1 to 6, and I have my 4 manufacturers listed on the horizontal axis. Now, a thing to note here is, you see how the vertical axis has the arrow up? Because, of course, frequency is going to keep increasing, but my horizontal axis doesn't have an arrow to the right because these are my only 4 manufacturers, right? And they're not numbers, right? This is qualitative data, not quantitative data, right? If this was quantitative data on the horizontal axis here, I would probably put an arrow at the end of the axis. But since it's qualitative, I'm just going to put a line that actually has an ending to it, okay? It's not going on forever, all right? So now what I'm going to do is I'm just going to create my bars here. All right, so Nabisco, the bar should go up to 2. So let's see if I can do this neatly here. Right, Nabisco was 2. So there's a bar there. And then General Mills was 5, I believe, right? It was 2544, right? Yeah. General Mills was 5, so I'm going to go up to here, about, right? And you want to try to make the bars the same width, if you can. So there's my bar for General Mills, that goes to 5. And then Post and Kellogg's were each 4, so I'll put little rectangles there, little rectangular bars at 4 for Post and Kellogg's. So that looks pretty good, right? So that would be my bar graph for the cereal manufacturers. And an important thing to note here is, when you do a bar graph, the bars do not touch. Okay, the bars are all separated, right? Make this look a little bit nicer, maybe. Line it up a little bit better if I can. All right, that looks better, right? So that would be my bar graph for the cereal manufacturers, which is the qualitative variable. So we're still working with our sample of 15 cereals, but now we're going to deal with the quantitative variables, right? The numerical data sets. Okay, and the numerical data sets were fat and sugar. Okay, so those were the quantitative variables. All right, and then they ask us to prepare a frequency and relative frequency distribution table for the quantitative variable sugar. All right, so we've already done a frequency table for the qualitative variable. Now we're going to do a frequency table for the quantitative variable sugar. Okay, so if we look again at our table, our sugar, right? Here's our sugar column, right? We're not dealing with the fat column, we're dealing with the sugar column. There's a couple cereals that have 0 grams, right, of sugar, so no sugar, and there's a couple that have as many as 6 grams of sugar. So when we list our quantitative variable, which is sugar, right, we have to list all values of that variable from the lowest, which is 0, up through the highest, which is 6. Okay, and you might say, well, you never looked to make sure that there was at least one cereal that had, like 1 or 2 or 3 or 4. It doesn't matter, right? What I do is I find the lowest value and the highest value, and then I must include every value between those, even if some of them, have no cereal that have that number of grams of sugar. I still have to include it, right? So like even, let's say 4 grams, no cereals had 4 grams of sugar, I would still put it in there and I just put a 0 next to it, right? So I must include every value from the lowest to the highest. So in this case, it goes from 0 to 6, okay? And then I'm going to do the same thing I did with my other table, right? I'm going to go down the list of sugar and I'm going to make little tally marks. So I have a 6, a 5, a 0, and a 5. So 6505, 6505, and then I have 1320. So 1320, and then I have 3534. So 3534, and then I have 636. So 636. All right. So now let's see what I got. So for 0 grams of sugar, there were 2 cereals. For 1 gram of sugar, there was 1 cereal. For 2 grams, there was 1. For 3 grams, there were 4. For 4 grams, there was 1. For 5 grams, there was 3. And for 6 grams, there was 3. So again, now I should make sure that the sum of those frequencies, right, is 15. So 2 plus 1 is 3, plus 1 is 4, plus 4 is 8, 9, 12, 15. So good. That works. Okay. So that's my frequency. Okay. But now this table also is asking for what's known as the relative frequency. And the relative frequency is just the proportion or fraction of the whole that each of those values make up, right? So in the case of 0 grams, right, that makes up 2 out of 15 of the cereals. For 1 gram of sugar, that makes up 1 out of 15 grams, right? And then for 2 grams, 1 out of 15. For 3 grams, it's 4 out of 15. For 4 grams, it's 1 out of 15 again. For 5 grams, it's 3 out of 15, which you could write this as 1 over 5. And then for 6 grams, it's again 3 out of 15, which is 1 out of 5. Okay? So the relative frequencies are always going to be fractions, right? They're always going to be less than 1. And since they're fractions of the whole, right, when you add up all of those relative frequencies, you should equal a whole, and a whole is 1. Right? When you add up all those fractions, 2 fifteenths plus 1 15th plus 1 15th and so on, you get 15 fifteenths, which is 1. Right? Of course, you could have written these also in decimal form, or even percent form might actually be a nicer way of expressing relative frequencies in percent form. The reason I didn't want to do percent form here is that 2 out of 15 is really not a nice percent to write. Out of all those percentages, the only one that's a nice percent would be 1/5, right, which is 20%. The other ones would not be nice, so I'll just leave those in the fraction form in this case. But they could be written as decimals or percents as well. All right. So relative frequency always must add up to 1 because it's actually the whole, right? They're all fractions of the whole, so when you take all the fractions of the whole, they must add up to the whole. Okay, so at this point we've created the frequency and relative frequency distribution table for the quantitative variable sugar. And now what they want us to do is use that table to prepare a frequency histogram or a relative frequency histogram. Now, I'm actually going to do the relative frequency histogram here. Through the miracle of video editing, you now see kind of a outline of a graph here, right? So I've given it a title. I've given it sugar content of cereal as my title, and I've labeled the vertical axis relative frequency because I'm doing a relative frequency histogram, and I've labeled the horizontal axis sugar content in grams. Okay, and you can see my horizontal axis is labeled from 0 through 6 because that's the different amounts of sugar that each of my cereals have, and I have not yet labeled my vertical axis. I want to go back to my table to do that, which I'll do right now. Okay, so if you go back up to the table, we can see that the relative frequencies ranged from 1/15 to 4/15. Okay, and again, I had mentioned this in the previous portion of the video when we created the table. It's not really a nice decimal approximation when you're dealing with 15ths. Now, if I was dealing with like a sample that had 100 cereals in it, then it would be nice because then all the relative frequencies would be nice decimals. You know, like in that case, if there were 11, it would be 0.11. If there were 27, it would be 0.27, so on and so forth. Right? But here, these are not nice decimals except, of course, for the 3/15ths. I'm actually just going to label my axes instead of in decimal form. I'm going to label my vertical axis. I'm going to mark off by 1/15. So I'll put a mark here. That'll be my 1/15. Then I'll put a mark here. That'll be my 2/15. Then there's 3/15. Then there's 4/15. And then 5/15, which there's none of, right, would be up there. So I'll label this here as before. Now I'm going to create bars. So there were 2/15 of the cereals that had 0 grams of sugar. So what I'll do here is I'll go up to the 2/15 and create my little box over here. And there's my first bar at 2/15 for 0 grams. And then 1/15 and 1 gram of sugar and 2 grams of sugar each had 1/15 as their relative frequencies. So I'll create another bar here at 1/15 for 1 gram, and then another one here at 1/15 for 2 grams. Okay, so I've done 0, 1, and 2 grams. I didn't make that perfect, sorry. And then for 3 grams, there were 4/15, right? It had a 4/15 relative frequency. So again, now over here, I'll go up to 4/15 for 3 grams, and that's my highest bar. And then 4 grams had 1/15. So that's back down here. And then both 5 and 6 grams would be 3/15 or 1/5, right? So that would be 3/15 about there, right? For 5, and then 3/15 again would be at 6. All right. So that would be my relative frequency histogram for the sugar. Okay, and again, of course, if you're doing, if you're handwriting this, you'd want to be using straight edges so that you'd be able to create straight lines and make the bars nice and neat. Okay, but again, as before, the bars get centered about the labels, right? So the bar for 1 is kind of like straddled around the label for 1. The bar for 3 is straddled around the label for 3, so on and so forth. Okay, so that would be your relative frequency histogram for the sugar. So we're out of the graph creating portion of this this handout, and we're into finding mean, median, and mode. Okay, so letter G here asks us to find the mean, median, mode of the quantitative variable sugar. Again, right? We had just created the relative frequency histogram for sugar. Now we're going to create the now we're going to find the mean, median, and mode for it. Okay, so what we would do here is first find the mean, and the mean is what, again, you think of as the average, right? When you say average, you normally think of the mean, and how do you find the mean? That little symbol there, the X with the bar on top of it, which is red, X bar, right? When you see this, you would say X bar. That's the symbol for the mean. And how do you find the mean? Well, you have this sigma X, which means sigma, again, means sum. We had talked about that in the tables before, right? So the mean is found by summing all the x's, right? So in other words, adding up all the pieces of data that I have and then dividing it by n, which is the total number of items in my sample, right? So in this case, we have 15 different cereals, so n is going to be 15, all right? So what we have to do is just add up all the different sugar amounts, right? So what are the different sugar amounts that we had? Well, again, I could go back to my table, and actually this would be a nicer way to do it. I already have the frequencies of each of the amounts of sugar. So in other words, 0 grams, there were 2 of them. 1 gram, there was 1 of them, so on and so forth. So what I could do, what's a more efficient way of adding up this this data, is by multiplying the quantitative variable by its frequency. So in other words, I would do 0 times 2 plus 1 times 1 plus 2 times 1 plus 3 times 4, and so on and so forth, right? That's an easier way, quicker way, especially if you have a lot of data, of summing up the data. Now you see what I've done here. That calculation on the top is always the data value times the frequency. Now again, did you have to do it this way? No. You could have just went and added up the 15 things individually. But like I say, when you're dealing with a larger set of data, this is kind of a nicer way to do it, right? So you just multiply the data value by the frequency of that data value. So when I do that, and then I add them all up, of course. So when I do that, I could probably do this in my head here, right? So that's 0, 1, so that's 1 plus 2 plus 12. So that'd be 15, plus 4 is 19, plus 15 is 34, plus 18. 34 and 18 is going to be 52. So this is going to be 52 divided by 15. And here I would probably want to get a decimal approximation, right? 52 over 15. So 52 divided by 15 is going to be 3.47, all right? So my mean here is going to be 3.47, right? So that's like the average number of grams in the cereal. Number of grams of sugar in the cereal is 3.47, okay? So that's the mean. And then the median and the mode, really, now that we've organized the data in the table, they're going to be easier to find, okay? So the median, as you can see the little definition down here, how to find the median, right? You rearrange the data from low to high, which is basically already done in our table, And then if the data set has an odd number of entries, which we do in this case, where we have 15 entries, the median is the middle data entry, right? So if we have 15 data entries, the middle data entry in this case is going to be the eighth entry, right? And the nice thing about it is you say, well, the eighth entry from what side? It doesn't matter what side you're counting from the low end or the high end, because the eighth entry is going to be the same from either end because it's in the middle, right? So you're taking the eighth entry, whether you're looking at the eighth from the bottom or the eighth from the top, okay? So I can go back to my table and get the eighth entry, right? The frequency tells me how many entries there were. So there were 2 zeros, so that's 2. Then there's 1 1, so that's 3. There's 1 2, so that's 4. And then there's 4 3s. So the 5th, 6th, 7th, and 8th entry would all have been 3. So the median here is actually going to be 3. So the median would be 3. And then the mode is easy. The mode is just the data entry that occurs with the greatest frequency, right? So the most popular one, in other words, right? So which one is the most popular from my table? Which one had the highest frequency? That was also 3, right? There were 4 3s. So 3 again would be the mode. All right? So they were all very close together, right? I mean, the mean is 3.47, the median is 3, and the mode is 3. So they were all pretty close, right? So that would be your mean, median, mode. Okay? And again, the median and the mode, once the data is organized, right, in order, and you've found the frequency of each, it's very simple, right? So the median and mode are easy to find after the data's been organized a little bit.